Hey you guys, how's it going? We're talking about exponential change with percents, and I found a fantastic example straight off the headlines for you guys from today. There's someone whose name you might have heard before. Her name is Angela Merkel. What's her job? No big deal, just the Chancellor of Germany, okay? And as the Chancellor of Germany, she has a solid science and math background. Let me let you check out this video of her breaking it down about how the exponential growth of the virus through her country can be controlled through certain parameters, but could not through others. And it's pretty tight. I mean tight parameters, not tight like awesome, but actually both.
Die Kurve ist flacher geworden. Es bleibt nach wie vor so, sie muss so sein, dass sie unser Gesundheitssystem nicht überfordert. Und wir haben Modellbetrachtungen gemacht. Wir sind jetzt ungefähr bei diesem Reproduktionsfaktor 1, also einer steckt einen an, der natürlich auch nicht, das kann ich immer nur für eine Infektionskette sagen, ob einer einen ansteckt, das ist dann ein Mittelwert, aber es ist ungefähr einer steckt einen an. Schon wenn wir darauf kommen, dass jeder 1,1 Menschen ansteckt, dann sind wir im Oktober wieder an der Leistungsfähigkeit unseres Gesundheitssystems mit den angenommenen Intensivbetten. Wenn wir 1,2, also jeder steckt 20% mehr, 1,2 an, also von 5 Menschen steckt einer 2 an und 4 ein. Dann kommen wir im Juli schon an die Belastungsgrenze unseres Gesundheitssystems und bei 1,3, das hört sich nicht viel, wir kommen von 4, 5 Ansteckungen, 3 bis 5 Ansteckungen. 1,3 sind wir im Juni an der Belastungsgrenze unseres Gesundheitssystems. Daran sehen Sie also, in welch kleinem Spielraum wir uns aufhalten. Und die ganze Entwicklung basiert darauf, dass wir davon ausgehen, dass wir eine Infektionszahl haben, die wir überblicken können, die wir nachverfolgen können und dass wir mehr Schutzkonzepte haben und durch die mehr Schutzkonzepte auch mehr Lockerungen machen können. Aber es ist ein dünnes Eis, wie Herr Tschentscher gesagt hat, oder eine fragile Situation oder wirklich eine Situation, in der Vorsicht das Gebot ist und nicht Übermut.
All right, wow, okay, cool. Thank you, Angela. And if you caught that or not, you might have realized that she just threw 4 functions at you, okay? She wasn't really clear about the time frame during which she is referring. So I'm going to assume that she's talking about per month, okay? So let's take a look at what those functions are, okay? So we're assuming she's talking about time periods of, let's say, a month, okay? So we're going to say that her initial report was that A being the number of sick people in Germany, and we're making a function of time, a function of time where x is the number of months, A being the number of sick people in Germany. She says, if the number of sick people in Germany each infect one other person over some given amount of time, that the country is going to be okay. They've made models, they've consulted mathematicians, like, you know, smart people like me and Matt, and have identified that should be fine. They can handle that. That flattens the curve to the degree that their healthcare system can deal with it. However, she says, crucially, if the number of sick people in Germany, this A value, each infect 1.1 people over a month, then the whole healthcare system in Germany will collapse by October of this year. No more hospital beds, doctors and nurses overwhelmed, supplies used up, apocalypse, bad, terrible. Ms. Merkel goes on to say, if we're looking at f of x equals a times 1.2 to the x, in other words, all the sick people in Germany each infect 1.2 people per month, the entire German healthcare system will collapse by July. July is so soon, you guys. It's May. Oh my God. Okay? It's a big deal. And then the most dramatic evidence that she supplies is this function right here. This is the one that scares us. If each sick person in Germany infects 1.3 people per month over some given amount of time, the entire healthcare system in Germany will collapse. What do you think? How much time do you think we would have? Not we necessarily, Germany. They would have until June. That's it. Do you see the huge difference that's being made between a situation up here where each person infects one other person per unit of time? We'll be all right. Each person infects 1.1 people. Big trouble by October. 1.2 people, big trouble by July. 1.3, big trouble by basically right now. So notice the extremely powerful effect of a logarithmic, an exponential function. When you just change that base slightly, you're changing everything because it's interacting with the exponent. The base and the exponent come together and they create this synergistic, explosive relationship where things get bigger, and then they get bigger because they're already bigger, and because they got bigger, they're getting bigger. Epidemics, right? Okay, guys, that's a good example right off the newspaper for you. Thanks for listening.